Are you? So now we would be starting with the work energy power, and first topic is work. So let's start with work. So work means, like, if suppose there is a body and there is some force getting applied here and it is at some theta angle. So we will see that how much distance or displacement has been done on this object. So how much this object has moved. So the basic formula is F vector dot S vector. Dot here is dot product. Like if you are good at vectors, you must be knowing it that this dot is dot product, and this F is a force vector, whereas this S is also another displacement vector. So this is vector, F is vector, S is vector, but this work is a scalar quantity. So it becomes Fs cos theta. So theta is the angle between both of the vectors, we can say, because this S is the plane with it moving and this is the force, so this is the theta. Now if you will put, if we say that this F, if we make into two components, this F will become, this is theta, so it will become F cos theta, and this will become F sin theta. So when we need to know that what work this force is doing and what work this force is doing. So when we will put sin theta, so work by the at the y, in the y-axis we can say it will be F sin theta dot S, and cos theta here is 90 because theta is the angle between the force, because we are taking this F sin theta and this is S. So this is cos 90 and cos 90 is 0, so everything becomes 0. And this is the work in the x direction, that is F cos theta dot S dot cos 0 degree. So this cos 0 will become 1, so it will become Fs cos theta. So that's why we directly use, we say that work formula is Fs cos theta. Okay, so this is the concept behind this formula, that why we are using Fs cos theta. We basically always use Fs cos theta, but we never know that it is a dot product, and then when we put it the values, then it automatically come as Fs cos theta. So like now you know this theta is the angle between the movement and the force. Like for the circular motion, the force will be towards the center and motion will be towards there, so it will have a 90 degree. So 90 degree means cos 90 is equals to 0, so work done by the centripetal force is always 0. So you have to take care of all these types of examples where the angle is 90, it will become 0. And this was the first important example. Now the second one, the way the questions would be coming. In the second thing I want to tell you is, there will be some questions where it would be given to you that F and S graph will be given to you, and the area under the curve will give you work done. So area under the curve for Fs will be work done. So if it is triangle, use half AB. If it is something trapezium or circular or like quadratic, So depending upon the shape, you have to use the area under the graph. Then there is power. Power is like, we say that this person has more power than me because he can do that same work in lesser time or more work in the same time. So basically we compare the work with time. So we say the definition is rate of doing work. It means that the work upon time becomes the power. Change of work upon change in time. And we have already discussed that work is F dot S. So I'm not writing cos theta, like cos theta is 1 when the movement and the force are in the same direction. So cos 0 is equals to 1. So I'm just writing Fs. So P, so this is the first thing that you have to remember. The second thing, the second formula is Fs upon T. And this S by T becomes V because velocity is S by T. So in many questions, you have to use this formula. So always remember that work by time is power, and another formula is V, F into V, where F is constant. F is constant, then only you can use this. Otherwise, you can't use this formula. Now, if F is variable, then how you will solve it? So if F will be variable, there will be some graph given to you that this is the force and this is the velocity, and it will say like this, that force is increasing and velocity is increasing. So now the area under the curve will give you from like velocity 1 to velocity 2, it will give you power. So now topic completed for power also. And yeah, for energy we will use this power is equals to change in total energy by total time. So after this, now we would be moving towards the energy in the next video. So I have just written this formula here because this is a formula for power. This is also very important formula. In the next video, we would be discussing all about energy. Okay, then thank you for being here. If you still have some doubts, just put it into the comment section so I could see that how you feel about. Thank you for being here.